presentation on power. We're not going to get real deep about anything. Very Aries related. I went down, was it January, to the training center, Felton, Michael, Melinda, and Steve, and went to the power session, and I walked into it kind of feeling confident, like I probably knew it and it would just be a review. And just like always, I learned something new. So I'll share that with you today. There is a test coming up shortly, so pay attention. Real quick review for about everybody. DC power supplies, 12-volt DC power supplies. And I've got examples of a lot of it up here. How many people know the difference between switching and linear? Go ahead, Bill.
Okay. Linear is the more traditional old style. It uses a transformer, and it has usually a full wave rectifier and etc. to transmit AC from the line at 120 volts to the 12.8 or whatever it's outputting in DC.
Yep. It's an older design. They're heavier, less noise. When we talk about noise, we're not talking about noise like a hum or a buzz, but noise that would interfere with the radio. RF that would come out of that power supply and go to the radio. So the linear power supplies typically be a bit more expensive. They're heavier, less noise. Switching power supplies, when they first came out, had a reputation for being fairly noisy. They're less expensive, lighter weight, but could be noisy. I think there's been, everything I read about it, there's been a lot of improvements with the noise, so I've got a switching power supply and I do not notice any noise coming from it, but I'm big on using ferrite to filter any kind of noise out that I can. Felton, you raised your hand up as well. What did I miss about the differences between the two? What kind do you have, switching or linear? Or how many of each? Yep. Yep.
But portable, I took MFJ switching power supply with me to Honduras on a couple of occasions. I didn't experience any noise.
Yep. I'll tell you, getting up and doing something at the club meetings is kind of neat because you don't have to know everything about the topic you're talking about. There's so much expertise in the room, you can draw upon that knowledge around you. So as we try to get more people to present, keep that in mind. You can always go ahead.
Are like if you're running a linear, for instance, from a generator, it would probably convey less noise than a switching running from a generator. Would that be accurate? Or?
I don't know. That may relate to our test question.
Okay. Probably yes, because of the full wave rectifying system they have in it. The problem with the little generators are they a pure sine wave inverter output?
Yep, you're getting ahead of this one is. We're going to talk about generators shortly. So something you typically use at home, or if you got deployed and we're using a mobile station or even a base station, convert AC power, like you'd plug in the wall or to a generator, into DC power that you could run a radio from. That's the purpose of them. Things you...
Tube units, if you run into old hand radios that use tubes, they have built-in linear supplies, and you learn about what heavy is.
Oh yeah.
75 or 80 pounds just for the transformer.
Well, and like a linear amplifier, maybe in two cases. They're so heavy they had to split it up into two. Things you got, basic formula when you took the tech license, volts, watts, and amps. Yeah, it's pretty simple. Volts times amps equals watts. So big difference when you're working with 12 volts instead of 120. So the size of the wire can get fairly substantial with DC power. You don't have to have a lot of amps where you got to start going up in gauge. And this is one of the things that Barbara, I picked up when I went down to the training class in January. mobile amateur radios. We say it's 12 volts, but what are they really designed for? 13.7 or 13.8. That's what most cars and trucks. My power supply, it's got I can adjust the voltage, or I can click the button and fix it and it'll hold 13.8. I just leave it unfixed because that's what the radio is designed for. What happens if you run it on 12 volts? Let's say you've got a battery back, this is a battery backup. So let's say I'm at home and we're doing the Aries check-in and they say, are you on emergency power or not? I'll look over and make sure I've got my power supply, my DC power supply turned off, so I'm running from the battery. I have a voltage drop because I'm now pulling off of a battery. What happens to my radio?
Most of the newer models will shut down. Well, the transmitter part will give out less power quite often. So if you said you have 50-watt mobile VHF, UHF, you may drop down to 35 or 38 or something like that. Because the voltage drops.
And they'll run hotter.
Both correct. Less efficient, runs hotter, you put more strain on the radio, and you're outputting less power. It's less efficient.
And ICOM radios love full power.
Yes, they do. And I happen to have
Low on them, they don't like it.
I happen to have ICOM radios, so they like the power. So that's the thing I picked up on when I went down to the training session. Any questions before we move on? That's very basic. Dollar for dollar, switching power supply, way less expensive. Less noise would be the linear. We already talked about the early switching supplies. Significant noise, new ones are way better. Weight switching power supply, I think Felton calls his linear the brick, and they are heavy. There's a link there if you want to read about the differences between them. I found that article on DX Engineering. The prices are pretty similar between DX Engineering, ham radio outlet, and gigaparts. Sometimes be a little bit less because we don't pay tax here in Georgia on that. DX Engineering is a great resource for me to go and learn. They tend to do a better job of putting good information out there. And I found this article on linear versus switching power supplies and wanted to share it with you. Let's talk about batteries real briefly. All different types. There's lead acid, traditional, like you probably have in your car. A lot of us have. Felton looked like, I didn't look the last time I was in your shack, but some time ago I did. It looked like a car battery. Is it a lead acid or an HEM?
Just a marine battery.
Marine deep cycle? Okay. Deep cycle versus just a car battery that's designed for cold cranking amps. Deep cycle battery tends to cost a little bit more, but it's designed to be drawn down and charged back up. If you draw a car battery all the way down, it may die. You know, you've definitely weakened that battery. They're just not designed for it. The chemistry in it and the engineering inside, it's not designed to be drawn down that much, where a deep cycle is. So you get a longer life if you have the right type of battery. Then there's lithium ion. What benefit does lithium ion have over a lead acid battery?
There's no memory. You don't have to completely discharge it to get it full
Okay.
charge.
When the voltage goes below a certain point, the
Battery, it's got a protection in it to shut down, keep from damaging the battery.
it'll stop.
Michael said lighter weight.
I believe they have a more consistent voltage over the discharge side.
More consistent voltage over the discharge cycle.
And it can be charged and discharged many, many more times than a lead acid.
Can be charged and discharged many more times. So let's think about that for a second. Might a lithium ion battery cost more than a lead acid? Yes. But how many charge cycles can I get out of a lead acid versus a lithium ion? So it's that matter of economics. What's my short-term budget versus my long-term budget? Because if I buy the better battery, it'll probably last longer. It'll have more charge cycles. Then there's the lithium iron phosphate batteries, like the Bioenno. Boy, they're way lighter weight. They operate at a little bit higher voltage, closer to 14, so they're closer to the design voltage for the radio. Have to have a different charger, a higher voltage to charge them. Way more charge cycles, up over 2,000 for most of them. Most of them have electronics built into them. Where you're charging it, it balances the charge over all the cells that are in the battery. And the number of cycles is way higher. They're super duper expensive though.
$1,200 for a 500 or 500 battery.
Yeah.
Some of the newest ones have a temperature blocking system in them, because if you try to charge them at too cold a temperature, you ruin the battery.
They sure do. Yep, Bill shared that they have in the circuitry inside the battery a thermal protection, not for it being too hot, but if you try to charge a LiPo battery at too low a temperature, it can ruin the battery. So they have thermal protection built in to keep it from charging at too low of a temperature. Yeah, if you're in, it's all about the application. So if you're going to be going out in the Arctic, probably don't want to take a lithium iron phosphate. For most of the uses around here, it's pretty safe. We do get cold in the winter, but so you know, how are you going to be using it? What are you using it for? At home, I use a lead acid AGM, where it's I guess it's a glass, almost fiberglass substance inside the battery, and it's a lead acid technology, and it's extremely. I didn't bring it because it's too heavy. I didn't want to carry it in. It's bigger and heavier, 70 pounds or so. I've got it in a little bit bigger box than this one. This is a LiPo battery, 40 amp hour, 10 pounds or so.
What they call gel batteries. Is that
Yep, AGM.
That's what you're
Mm-hmm.
speaking of?
Yeah, they're a little bit better for portable use, but they're still very heavy.
If you flip it over, it's not going to leak out
No,
acid.
no, they've got the chemicals are in a fiberglass or a glass.
Right.
Not, you know, if you kept it upside down, it's still going to be a problem, but they tend to be sealed.
Right.
Most of them are sealed acid batteries now. Any other questions? I mean, you could spend an entire day talking about batteries, and I do not have the knowledge to do it. But if somebody's got a question, we may have somebody in here. The guy at the front up here kind of knows way more about them than I do. And Rob, you could probably, something I learned from you, I've heard you talk about it several times, don't store a battery dead. What is it? It builds up?
Lead acid batteries with phosphate. The lead will deteriorate off the plates if it's not charged.
The lithium ion will also oxygenize, and that kills their storage capacity.
Yeah, a lot of knowledge in the corners of the room over there.
You want to keep them charged above about 30%.
Yep.
They'll slowly drain if you just leave them on a shelf.
So keep them charged. You want to store your batteries charged. You want to maintain them.
What's the type of battery that they're using in drones? Lithium,
Lithium iron phosphate would be my guess, because it's a lot of power,
high rate
lightweight,
discharge. Yeah.
very high rate of discharge.
The newest lithium iron phosphates use a carbon nanotubes or something to coat the cells, and they charge in 1 minute.
I've heard that if things go bad, they catch on fire.
The lithium iron phosphate do not explode. They don't oxidize. The lithium actually leaves the cell charge.
You get a fast
100%.
charge rate.
They don't. You can heat them up by overcharging them, but that's about it. You have to really abuse it to catch it on fire.
See the new electric cars, you charge them 80% in 15 minutes.
Mm-hmm.
Lithium iron phosphate.
Yep, lithium iron phosphate's the newer technology.
Most of the newer handhelds have lithium ion.
Yes.
Is the high power.
Mm-hmm. Yeah, a lot of the laptops and a lot of the HTs use a lithium ion because of the weight. You get a lot of power into a smaller space.
I remember the old Icon handhelds that were like the old 2AT, you know, with a lead acid battery. I mean, it was huge.
Mm-hmm.
It was heavy.
They're
Yep.
also non-toxic. The lithium iron phosphates are non-toxic to the environment. The regular lithium ions
They can dispose of them.
are the lithium cobalt is toxic.
So kind of similar to the power supply with the battery, you kind of need to know what application you're going to have to be able to fit. So which battery's best, you got to know how you're going to use it to know which one's best. When I was looking something, I was studying the specifications on them, and I wanted to be able to charge at a 5 amp rate. I had to go up in size the battery because anything below a 40 amp hour, I could have only charged it 1 amp hour or a 1 amp rate. So it could have taken me, if I had a 20 amp hour battery, it could have taken me a long time to charge it. Have to run the generator to charge it, so I didn't want to be having to burn gas and make the noise a long time. I went up in size just to get the higher charging rate. And that was because the controller that I've got can do 1, 5, or 10 amps charging rate. So if you're going to invest a lot of money, study, ask somebody that before you do it, because you might get something and get a surprise and be disappointed with it.
That's a West Mountain radio.
Mm-hmm. Bill?
I was gonna say, what's always worked for me is the best kind of battery is the one I can afford at that time.
Yep. Yeah, there's a lot of truth in that. Yeah, but batteries are so, especially now, gosh, you could put a fortune into them. Very, very expensive, but the technology is amazing for what you can get. So the best one is what you can afford at that time, yeah. But it's also that long-term budget versus the short-term. Get a better battery now, it lasts 20 times longer than the cheaper one. So that bargain is not always such a bargain. So if you make a well-informed decision and get whatever's best for you, then it's been a good day. Let's talk about emergency power. How many of you have some way of automatically failing over your power for your radio if the power goes out, if the commercial grid went down to your house?
Not automatic, not
Manually?
manual.
Okay. Bill, you've got an automatic?
No.
Manual? And Felton, you've got a West Mountain Radio power gate, I believe.
Yeah, okay.
Super power gate? Just power gate? Okay.
You never even know the power went out.
No. Well, you go from 13.7 to whatever the battery's putting out.
Yep.
That's it. You don't hear anything, you don't notice anything. You could be in the middle of a transmission, it's so fast.
How fast is it? Millisections probably.
I can look it up for you later. I did bring the book with it. Figured there'd be some kind of question I couldn't answer, so. West Mountain Radio are the ones I'm familiar with. I saw Felton's before I ever bought one. I've got two. There are different types, and you need to figure out what kind of battery you're going to have before you buy the automatic failover and charging system. There's the power gate, the super power gate. The Epic power gate came out about a year ago when the lithium iron phosphate batteries came out. If you're going to get a lithium or a LiPo battery or lithium iron phosphate, you have to have the Epic power gate because it will charge that battery. The others can run the battery, unless the battery's got circuits in it to protect itself. So this is an Epic power gate, lithium iron phosphate battery. It's got, guys, get up and come on up if you want to. You're welcome to. Just easier to see. So this little device, we've got battery in, so this is just coming straight from the battery. Power out, that's going around to the back where I can distribute it to multiple devices using Anderson power poles. Power supply, so this is coming from going from AC to DC, power in.
That charges it.
We've got a solar panel charger. So if I've got a solar panel, daytime, I can hook, so this is great for any kind of deployment, any kind of Aries deployment. Take about a 30 watt solar panel with you, hook it up, and you can charge the battery all day long. And it should last all the way through the night. Never have to burn any fuel. That'd be for emergency only.
Yeah.
On YouTube today, I happened to run across a young man who was describing he tests all of the new power supply battery combinations,
Mhm.
and there's one called Blue Getty. He said, why do they name it Blue Spaghetti? But Blue Getty for $1,299.
Whew.
But it's a 100 amp hour battery, plus it takes
Mhm.
solar charging, plus it'll take car charging, plus it'll take wall charging, it'll take just
Yep.
about anything.
Something like that,
Yeah, this one should do all that as well. Yeah, you could come in, for the power supply coming in, that could be from a power supply, it could be from
car.
a car. It could be from, any DC power source you've got that would be at enough voltage. And I think the range for input power was, I'd have to look it up. Maybe it's here. Nope. Yeah, I think it goes up to 18 volts for the max. I don't remember what the bottom was.
How heavy is
Going on
it?
memory.
That's not bad.
That's a 40 amp hour battery.
Oh, that's a 40?
That's a 40.
That's not bad.
Yeah,
Even
go
I-
ahead.
Even
Anybody.
I could carry it.
Yeah, not bad at all.
But for a 40, that's
A
lightweight.
good example is the car battery is 90
Yeah.
amp hours, so
Exactly.
almost half
Yeah.
as much.
Did you
power.
build the box?
That's about in a 40.
Yeah, I got the 30. I mean,
Yeah,
Did you build the box or did you buy it?
Oh, I bought it.
You bought the box? or-
Yeah,
Box, and it was already accessorized.
this one was. It was the exact same price if I bought the components separately. So I'd bought it already
You're right.
assembled. Yeah, had to wait about 3 months to get it. I think I ordered it in December and got it in March. A lot of people getting them.
wow. Did you ever open the lid?
Yeah.
just curious what's inside.
It's a 40 amp hour Bio battery and a little bit of foam to stabilize it while I bounce it around. Don't have to ventilate that battery.
What, about 500 watts? Roughly?
40 amp hour,
Amps times volts.
yeah, right around 500.
I told the guys at West Mountain that they should make them out of cheese because they're made out of Wisconsin.
Yeah. So what you want to, you kind of got to do the math before you start putting your system together. What kind of radio is going to be operating for how long in what situation, or what's the worst case scenario you want to be able to cover? How many volts? So we already talked about if I lost this power, my battery, particularly the one I have at home, which is lead acid, it's not going to put out enough volts to keep my radio happy. And Felton made the comment that ICOM radios really like to run at the correct power.
Absolutely. I know
So
706.
I hadn't even thought about it. And Barbara,
100 will run down to about 12.
706.
Yeah.
we'll go ahead and flip the slide down for the next one. You notice the connectors I had on here. I wanted to mention them. If you want to participate in Aries, strongly recommend the Anderson power pole connectors. How many people already use them? High percentage. It's definitely the standard for Aries. In this area, is it the standard nationwide? Yep. So if we were, let's say we're going up to the top of the mountain, something happened to Felton's power, I happen to have mine, or I guess I live the closest to that location. If I ran and got mine, your radio would plug into, we don't have to do any change in wiring.
That's why it's standardized to the Anderson power pole, so
Yeah.
swap out, trade, share.
Yeah, and they're about dummy proof.
And pretty much outside, if you don't have a lot of light, you don't have to worry about messing up.
No,
Red on red and black on black.
you can buy the connectors. The key to it is having the correct crimping tool. It's a ratcheting crimper, so you get the correct pressure on it. And everybody doesn't have to have one.
I do it for a while, it'd be much easier with.
Well, I've got it, so if you're going to be putting connectors on, just let me know and we'll get together. It's got dies for the 15, 30, and 45.
And I've got some things that I ordered off of eBay. A lot of times you push, like if you're a jumper cable, you're going power pole to power pole.
Mm-hmm.
It's it's not hard to pull that back
No,
apart.
pulls apart real easy.
They make a little
Little
two-prong
clamp.
thing that goes in the roll pin holes on both connectors that kind of stabilizes that.
Hmm.
But they're not real stable looking cord to cord. They will pull apart rather easy.
They do. Yeah, just carrying this over here, I put it in a tote and brought it in. It pulled a couple out just in moving it, so they do come out. Yep, standard in Aries. I think it's the de facto standard in amateur radio. Everybody seems to be using them now. Should have bought stock in that company before they did that. So I've kind of got stuff lined up in, going this direction, going down the line as you connect everything together. How many of you have a generator? Golly bum, way more than I expected. So this is review for about everybody. Pros and cons, there's gas, diesel, propane, solar. People don't really think of solar as a generator, but it's a generator. It's an alternative to running fuel through one of these others. Pros and cons of gas.
Gas goes
Gas.
down.
Extremely flammable, very accessible,
Very accessible, very flammable,
Gas tank was empty.
burns it fairly quick.
over time, if it sits in your system, it lacquers up.
Stability. So getting gas with no ethanol in it helps a lot. If it's a carburetor system, which most generators are, running that carburetor dry, so is there a fuel shutoff? I have a larger one at home, and when I run the gas in it, turn the fuel off, let it burn everything out of the carburetor before I ever store it.
And additives.
And no ethanol whatsoever at my house.
If you have to use ethanol gas, make sure you get Startron or.
PRI is the one I favor.
They stabilize the gas.
There's PRID and PRIG, one for gas, one for diesel. They help a lot.
We don't think about this here because we live in Georgia, but if we're up in Wyoming, say, gasoline burns a lot longer at frigid temperatures than diesel.
Mm-hmm.
And diesel, I'm trying that.
Have
out
diesel
real quick.
gel up on you.
I find that the gas tastes terrible when you go to siphon.
Yep. You know,
It doesn't have a good flavor.
what percentage of movies have somebody siphoning gas and making the funny face and spitting it out? So when we have our play, Bill's going to take on that role. He's got it down. Pros and cons of diesel. Longer storage, more stable for storage, years, less flammable. Generator tends to be a little bit more efficient. I've got one of each at the same power capacity, and the diesel burns less than half of the gas.
Yeah, 'cause the engine's been a lot lower.
Lower RPM.
A lot of times with the diesel too, you're more able to run alternative fuels. You can use some that'll,
You can run kerosene,
was that?
you can run kerosene.
Much full.
Yeah.
Cooking oils.
Oh,
Depends on the diesel engine. Small one like my generator would probably be more sensitive because it's a smaller engine.
Yeah.
Some of the larger ones, yeah, they're very flexible. A lot of the military ones are very, very flexible.
You can dump just about anything that'll burn for.
Yep. Propane. What's the benefit of a propane generator? Right, let's do pros and cons.
So you can,
So propane, the fuel would store indefinitely. It won't.
You were saying it's cleaner, so if you gotta do oil changes, propane probably be not as often compared to gas. I believe if you have stuff burn clean enough, you can even burn propane indoors. Maybe not.
I wouldn't do it for a generator.
Okay.
Yeah, it's got to be exhausted outside.
Yeah. Yeah, that'd be bad.
But con would be lesser accessibility and
I would think there'd be more.
You could run out quicker.
Right, and methods of storage of it. Cylinders are heavy.
They are.
You can't run to the store everywhere and get your,
Yeah, but you
cylinder
can go to
filled
a
up.
hardware store versus you don't have to go to a gas station to get gas. You can only get gas at a gas station. A lot of times you can get gas and propane at a lot of the, and diesel. So
Yep.
I
I guess it just depends on what's available near you. What are the sources? You know,
And for a whole home generator, propane would, or natural would be your,
And I-
fuel of choice because you can store larger capacity.
I left natural gas off there because I live out and don't have it available to me and haven't for many years. But there are a lot of natural gas generators, especially the whole home size. There are generators that are dual fuel or tri-fuel. So you can buy generators that, pardon me,
I can get a kit for my generator
to convert from gas to, okay,
triple fuel.
yeah. So, you know, it's all in what works for you, but just some pros and cons if you're thinking about it. Solar, you know, pro is quiet, no fuel required.
Taste?
Tastes better. Doesn't work so good at night unless you've got a good battery to store it in.
Well, if you eat a lot of beans, you know, you can.
So solar, you know, if you're going to be without, let's say the power, tornado came through, hurricane came through, you're going to be without power for weeks. Solar would be really good if you had some capacity, because if fuel wasn't available, it would, as long as you had daylight, it could be a cloudy day. You're still getting some power. May not be 100% of what you'd get on a sunny day, but you'd get something. If you have batteries to store it in, you need to have enough battery to get you through the night or a couple of bad days. But definitely a good option. With generators, I think somebody mentioned it earlier, pure sine wave versus modified sine wave. Does everybody understand what that means? Or do you just heard it and don't know? This is a picture of alternating current, or AC, and it says 1/60th of a second, and that goes from the starting point for the up cycle to the when it crosses the zero voltage line on the downward cycle. Why do we know that's 1/60th of a second?
Because we have 60 cycle AC.
Because in the US we run 60 hertz, so 60 cycles a second. That's what that means. The voltage goes from 0 to 120, back to 0, down to negative 120, and then back up to 0 would be one cycle. It does that 60 times a second. Now the pure sine wave is that nice smooth blue line. A modified sine wave is the squared off. So a lot of a less expensive generator is probably a modified sine wave. And this is actually a stepping modified sine wave. I don't know if I've got an image.
Do you have another one?
Yeah, I do. There we go. Like a bargain generator may look something like this. It's just 0 instantly to positive 120, back to 0, straight down to negative 120, and back up. If you do that, some equipment tends to be a little bit more sensitive to it. So when you're thinking about devices that may be sensitive to RF, like AC to DC converters, radios, not so good with modified sine wave. However, field day, what do we run on? Modified sine wave. Hadn't burned anything up yet. Just over a long amount of time, not as good. So just, if you're thinking about generators, be aware of it.
Are most of your inverters true sine waves or modified?
Depends on, so
What you spend on them?
depends on what you spend. So
So what about my Harbor Freight out there?
probably a modified sine wave. If it doesn't say pure sine wave, it's probably a modified. But great question. So I think I owe Scott some money for setting me up on the next slide. So inverters, we all think about that DC to AC inverter. You can buy them to put in your truck or your car. You can use them at home, hook it up to a battery, have 120 volts. How about AC to AC? It's really called a transformer. DC to AC, that's what we think about. DC to DC, why would we use a DC to DC inverter? change the voltage.
Volts to 5.
So, the thing I learned down at the training session, the Aries annual training session last January, strongly encourage you to go. I'm running my setup here. I'm going to automatically switch over to battery when the power goes out. I'm running 13.8 volts because you come out of the power supply into this device. It passes through the AC power. It doesn't do anything to it, just passes it straight through. So whatever it has fed to it goes out the other side of the radio. Until that voltage goes too high or too low, it instantly switches over to the battery. My voltage just dropped. Unless I'm going through a DC to DC inverter that'll step it up from the 12 or so volts up to the 13.8. Then my radio will still put out the 50 or 100 watts it's designed for. It'll run cooler and my ICOM will be happy and not give me troubles. And again, this is a DC to AC, pure sine wave. I believe it's, what is this? It's a 300 watt. So I got one big enough to do my laptop. And maybe an LED light if I needed some light.
Why would a LED TV?
Yeah. Yep, sure could.
I ran in my truck.
Yeah. So I sized them to, all this is out of my go box. I just pulled everything out to bring in for today. And I sized it for what I have and what my intended use is. I promised.
Inverter is DC to AC. A converter is AC to DC, like a battery charger maintainer. Is that right?
I don't know.
Converter.
What do they call this? It's a step-up regulator. They didn't call it an inverter. They called it a step-up regulator. A DC power.
Working on campers.
Yep. Yeah, I probably used the inverter term incorrectly in this application. All right. There's the, nope, wrong direction. All right, here's the test. Using a West Mountain Radio Super Power Gate or an Epic Power Gate with a modified sine wave generator, is the radio receiving pure sine wave or modified sine wave? How many people say modified sine wave? 1, 2, 3. Anybody else? Modified sine wave. Okay. How many people think it's getting pure sine wave? It's a trick question. That radio works on DC. So if you're running a modified sine wave generator into your power supply, you're probably not putting your radio at risk of frying it. You're putting your power supply at risk.
Yeah, that'd be right.
So definitely not as big an investment and way less sensitive to the power coming in. Probably not that big a deal.
Is there going to be a curve on the ground?
No. Rob is going to take over and finish out the presentation. Rob's done a lot with solar, knows way more about batteries than I ever will. And we need to swap out.
Okay, since we're going to talk about power, Dennis wanted me to come in and talk a little bit about solar because it falls right into the category of emergency power. I have, for several years now, I've been installing a few solar systems for different people, mostly friends. They come to me and say, hey, Rob, you know how to put in a solar system? And I'll say, yeah. It could be very expensive to do like a home or a business. A lot of the professionals, they charge astronomical prices because they know how to do it and nobody else does. So I'm going to educate you just a little bit, okay? If you look at my pictures here, at the top I've got a couple examples of a fairly large solar installation. Now this would be a grid-tied system where you want to sell electricity back to the power company. The battery system Dennis kind of covered already, you know, using something portable like this, where you could hook one solar panel to it for a 12-volt solar panel. This is more of a system to save you money, like if you want to power your house. So if you look at the first diagram, it shows an example of 9 solar panels all hooked in series. You got to think of solar panels kind of like batteries. The more you put in the series, the higher the voltage gets. And that's called a string inverter. I've actually got this set up here on my house. If you look at the second page, the top picture, there's my roof. And those solar cells are hooked in series. They all go to a disconnect and then to a 3,000 watt inverter, which is designed to feed the power directly back to the power grid. So what that does is it reduces my consumption. I'm technically selling power back to Georgia Power. And if I'm not using any power, it actually shows up my bill as a bill credit. I may have sold back 55 kilowatts extra or 100 kilowatts extra if I haven't used that power. The bad thing about that is we pay more for the power from the power company than they pay you for it, at least in Georgia. Now, some states, I've heard of people getting 20 cents on the kilowatt, 22 cents on the kilowatt if they have a good solar farm on their roof. And I wish we could do that here in Georgia, because that's more than we buy it. You know, we pay tax and all. I think Georgia Power is about 14 or 15 cents. What's TVA, Dennis? Tax and all.
12.7. Let me tell you why they're giving you less money for the power than they're charging.
Mm-hmm.
The cost of sharing the power is about 4 cents a kilowatt hour.
Exactly.
The cost of getting it to you is probably 5 cents a kilowatt hour. So the transmission lines.
Transmission costs.
Lines, the cost of debt. So they had to spend millions and millions of dollars to put those power plants in. The interest on those loans is about 2.5 to 3 cents.
So that's the majority of your power bill. It's not the actual power generation. Like he said, it's probably 4 cents a kilowatt for them to generate the power. So that's all they buy it from us for, wholesale. So unless you have a really big system like the one here on the right, it's not, you know, trying to sell it back to the power company is not really a good idea. You're better off to make enough that you're consuming. Consume what you're making, in other words, because if I am making, say on a good day, making 2,500 watts when the sun's 11 o'clock in the morning straight over the roof, if I'm using 2,500 watts, my meter's standing still. You don't see the little bar moving either direction. If I'm making excess power, the little bar starts to move to the left. It's sending power back. If it's moving very slow forward, that's ideal too, because it means you're making most of the power you're using at that time. Right. The one on the right is this picture down here, where there's 36 panels. That puts out about 11,000 watts DC. After we convert it through the inverters and send it to the power company, it's around 10,000 watts. There's a little bit of losses. Typically on any solar setup, whether it's big or small, you can count on about a 10% loss, 10 to 12%. So if you design a 1,000 watt solar system, you're not going to get 1,000 watts, never. You might get close to 900, you know, because atmospheric conditions, you know, dust in the air, a lot of factors there. Your inverter, most inverters that are designed for solar, 94% efficiency. Your wiring, the distance of your wire, the size of your wire, you may have a 1% loss in your wire or a 0.5%. Anyway, it all adds up to about 10 to 12% loss. So anyway, look on the second page. I got a few more pictures there. You'll see my inverter down in the basement. It's a 3,000 watt inverter. It takes all my solar power and converts it over to AC, 240 volts, 60 cycle. Syncs with the power company, sends power back to the power company if I'm making more than I'm using, which doesn't happen too often, fortunately. So anyway, I brought a couple things to show you. Dennis had some toys here, like a watt meter. If you ever want to go on solar, it's a good idea to get one of these to see what your appliance pull. If you want to plug your toaster into it, or microwave, or ham radio gear, anything, you can see how much wattage you're pulling, you know, in an hour's time. So that helps you with calculating battery size, even with something like this. You know, if you're going to run an inverter and convert this to 110 volts, you want to see how much power you have to size your battery accordingly. You know, if you don't have a big enough battery and you're pulling 500 watts, what did we say it was, 500 watt hour? So you can pull 500 watts for 1 hour, and that battery's dead. So anytime you design a solar system, you want to keep your wattage in mind. This is a big inverter, similar to the 300 watt. This is a 3000 watt. This is a modified sine wave. It has the square tooth wave like you showed on the diagram. 24 volt, you could hook a couple 24 volt deep discharge batteries to this. You could charge those with solar. You could run up to 3000 watts off this thing. They have 110 volt outlets, and you could hardwire it. Like if you had a ham shack or something, you know, you could hardwire your AC outlets directly to it. It's got a 30 amp fuse on the inside. A readout tells what your current wattage is, wattage or amperage. Plus it has 110 volt inputs over here. And you might wonder what that's for. It has a battery charger built in. So if you're not relying on the sun to charge your batteries, like if you just wanted to use it for a battery backup, it'd keep the batteries charged until an emergency, then you could run off your batteries. This is one I bought. I don't use it much, but I mainly got it for emergencies. If power was out for more than a day or two, and I had no way of generating power, I'd go get a couple car batteries and hook to it, and I would generate power on this. And since I have some solar, I could probably rig up a way to charge the batteries, keep them charged. Yep.
How much does it cost?
One like this, I think this was $399. Wasn't bad. A pure sine wave inverter, maybe a couple $100 more for one this size, 3000 watt. It's pretty strong though. I mean, you can run a window air conditioner on this thing.
The difference that we've seen is that the modified sine wave inverters will make like your compressor and refrigerator run a little weird.
Yeah, a modified sine wave can,
But a noise.
it'll make things run about 10% hotter. Yeah, so if you're running a computer or a laptop, the power supply may run a little bit hotter running a modified sine wave. Most of your switching power supplies, like Dennis was talking about, have capacitors in there to help if the power's not a true sine wave. Those capacitors will kind of smooth it out, get rid of the jagged edges on it, so to speak. But, you know, you can hook 50-inch flat screen TV to this, and it'll work just fine. But if you get your ear up to it, you hear buzzing. You hear the choke coils in the power supplies buzzing a little bit, you know, because it's not a pure sine wave. So most electronics, they do recommend a pure sine wave. You know, especially if they're sensitive, medical equipment, stuff like that, you don't want to use something like this. You know, if you've got somebody sick at home and they're on some sort of medical equipment, you want to use a pure sine wave or something like that. So anything safety related, that's what's recommended.
Hey, Ron?
Yes?
Yeah, mine's a 300 watt, yours is 3000.
Mm-hmm.
Doesn't mean you want to load it up and run it at 100% capacity.
Right.
What's
right.
the guideline for sizing them?
It's hard to say. It depends on the type of load. If you're running incandescent light bulbs or even LED light bulbs, you could probably get it up there 90% without damaging the inverter or overheating it. Now, if you're running motors, electric motors, compressors, then you gotta, it's a different ball game. Most inverter companies, I've actually talked to a few on the phone, including Ames Power, they don't recommend running more than 1,000 watts on a 3,000 watt inverter if it's an inductive load like a motor, air compressor. They're getting better and better with inverters. There's several companies now that make an 8,000 watt pure sine wave, and they'll start big air compressors and air conditioners quite well. They're getting better with the technology. But used to be well, here's an example. I saw a YouTube video one time. The guy had an 8,000 watt inverter, had it hooked to his whole house. He had a big solar grid, charging a big battery bank, and he's bragging about this 8,000 watt inverter he just bought. Look, it runs my central air conditioner. He had like a 3-ton or a 4-ton central air conditioner. And sure enough, about 6 months later, he had a video about how the inverter blew up. Because he was running, he was running like 6,000 watts, maybe 6,500 watts of inductive load through this inverter. Yeah, it was working, but it's too much power. It's going to blow up the transistors.
They kick on and off.
Yeah, the cycling.
Peak about
Yeah.
15,000
Yeah.
watts for just a few
An air conditioner compressor could pull 10 times the current just for startup, just for a split second.
That's what I learned with the.
Yeah, it's hard on inverters, yep. You got to really oversize an inverter if you want to run like an air conditioner.
That first kick up of the skill saw, it would handle that. but
Startup current.
my rigid chop saw,
Yeah.
miter saw,
Yeah.
it would not handle
Right,
that
which
emission.
there are some that do run those quite well, but you got to oversize it. You know, you need an 8,000 or 10,000 watt. I want to talk about solar cells just a little bit. I brought, how many of you actually seen a solar cell by itself? There's your 6-inch solar cell. That's what they put in the big panels like you put on your house.
Attempted to make a big panel by getting like the broken ones.
Yeah,
Cab.
I've done it, yeah.
I wouldn't recommend
I've done it. The reason I'm being so careful is this thing is super thin, about as thin as a playing card, and it breaks like glass because there's silicon. It's the same material that goes in your integrated circuits, your processors, and your computers. This is what they call an NP type silicon. There's an N layer and a P layer. The N layer is on top, P layer is on the bottom. The way these things go together, and I'll let you guys come up and handle one here in a little bit if you want to. Just if you break it, don't worry about it. These are extras. Here's some broken pieces. Just showing you that they're quite brittle. They use a copper, it's like a zinc-plated copper wire. They call it tabbing wire. And this wire is soldered to the top of the solar cell. There's actually a silver strip. You can put a little flux on it, and you can solder a wire to it. That is your negative terminal, the top is. On the bottom, you can see these little silver spots. That's your positive terminal, okay? So you take the negative from one cell, and you solder it to the bottom of the next cell, like batteries. What's amazing about these, this cell right here, you're going to think I'm crazy when I tell you this, but this cell puts out 8 amps. Right there, probably closer to 9. That one cell puts out close to 9 amps, 8.62. Maybe I can tell you. .94 watts, but it's a half a volt. So yeah, you're looking at about 8 amps. The voltage is very low, current is very high. So you string them together like batteries. You know, you want 1 volt, you hook 2 together. You want 12 volts, you have to have 24, 12 volts. If you want to have more than 24 to charge a 12 volt battery. Car battery is 12.5 volts. So in order to get your electrons to flow, you need more like 14, 15 volts. In fact, a lot of your 12 volt solar cells, open circuit, they're putting out close to 18 to 20 volts. You put a load on them, they'll drop down to about 16, so they can really put a punch to a battery, you know, to charge it. You got to push the electrons like water. Okay, anyone know what makes a solar cell work? Has anyone ever studied it? I'll tell you real quick, we won't take much time here. Remember I told you it's a silicon material, like a transistor, or in this case, more like a diode. The top layer of silicon is a N silicon. The bottom is P. Think of it as negative and positive. When they make these things, silicon by itself isn't very conductive. They have to dope them. I don't know if you know what that means. Transistors are done the same way. They put impurities in the silicon. The top layer, they put phosphorus in it. The bottom layer, they put boron in it. As soon as they add these impurities, the phosphorus tends to make the silicon want to be a negative charge. The boron tends to make it want to be a positive charge. A solar cell like this, maybe I can describe this right, it doesn't work unless it's a circuit. This has got a potential energy in it right now, okay, but there's nothing there to make the energy move. As soon as they sandwich these two materials together in the factory with heat, that's called the NP layer, okay? Some of the electrons jump from one material to the other. As soon as you do that, it creates a battery cell, okay? The thing is, this doesn't store energy, so you can't hook it up in the dark and expect to get power out of it. It's not a battery, but it functions very much like a battery. What happens is when light hits it, like this light right now is making it half a volt, maybe 1 amp. Anyway, what happens is the photons hit the material. It hits both materials. So it shines through the top layer, goes through the bottom, and it forces some of the electrons in the top layer into that NP junction, where the two materials meet. That's where all the magic happens. When those electrons hit that junction, they jump down to the bottom, okay? So now the bottom's got an excess positive charge. The top layer, a lot of them don't jump. They don't want to. They tend to get knocked out of the atoms into these strips. See these little fine silver strips? They put them real close together because they want to absorb those electrons. Those free electrons, negatively charged, jump up to that strip, mainly because the ones that jump down to the bottom have a positive charge on the other end of your circuit. So they they want to flow from negative back to positive, just like a battery. So what the photons do is they force the electrons down through the layer, driving positive electrons to the bottom, and then the negative ones at top flow back through the wire, completing a circuit. So that's how they work. That's a simple way to describe it. A lot of people don't realize this, but when you build a solar cell, like you were talking about putting cells together, if I break this solar cell, see what happens? That's how brittle they are. If I break this solar cell, I now have two solar cells. You can't put it back together. Okay? Not easy. Anyway, I have two solar cells. I could actually take the top of this, hook it to the bottom of this, and I could double my voltage. Now, this doesn't have as much current because it's smaller. But I've taken a broken piece of these, and I put 18 of them together and put a little silicone around them, stuck them to a piece of, like a picture frame glass, made a real cool 12-volt battery charger. I mean, it was putting out 10 watts, you know, pretty easy. So, yeah, you can, they come in different sizes. A lot of times you'll see, like on eBay, somebody will sell like little chip corners and stuff. All it does is cut back the current just a little bit, but you can still use them. So,
How do you make it flexible?
that's something I've never really studied. It works similar. They've just got a different material, but it works on the same process of the electron flow. But they got them now where they're flexible, and these are actually slightly flexible. So they may be able to put a material in there and make them a little more flexible. The flexible ones I've seen, you can't bow them more than about 30 degrees. But I don't think they're 100% silicon, I'm sorry. But anyway, when it comes to solar cells, solar panels, anything you do on a house like this or a big system like this, it's true you want to ground it. They have these little grounding blocks made just for solar panels. You put a stainless steel bolt on the bottom of the panel, and there's a set screw. You lay your copper rod between them, tighten them all up. It's called a lay-in lug. Get them in a bag like that. They got stainless steel clips going to the bottom of your panels to hook your wires together. And that's one last thing I want to talk about is mounting solar panels. You should always use the MC4 connectors they make to jumper these things together. I've seen people hook them up with wire nuts, cut these off. You really should use the good connectors because these are rated to handle the current of your solar cells. You start wire nutting them together and you got a bad connection, it could catch fire. When you get a lot of solar panels like this together, this string on my house here puts out about 350 volts DC. The good news is I can use small wire because at that voltage, DC pumps real easy. At low voltage, like a car, you got to have big fat wires. I'm using 10 gauge wire to run up to 3,000 watts. And really, I could have done it with 12 gauge. But I did the math. 12 gauge wire, I would have lost 1.2%. 10 gauge wire, I lose 0.56%, less than 1% energy loss, because I'm going about 80 feet down to my basement where the inverter is. So anyway, you should always use the proper connectors so you don't catch on fire or start a fire. Use proper grounding on your solar panels. If you're doing a small system, here's a charge controller. Anyone seen one of these? Yeah. You use it for one panel. This actually does 20 amp. This is a PWM charger. It's not what they call a power point tracking controller. This is a pulse width modulation. A little cheapy like you get on eBay. But you can hook a big solar panel to it up to 20 amp and charge a 12 volt battery or multiple batteries in series. Actually, this one will do 12 or 24 volts. You could have two batteries in series, and it doesn't matter on the input. You can use a 12 or 24 volt solar panel in, and it'll charge 12 or 24 volt batteries. Also has a USB for emergencies, so you could literally hook a solar panel to this, and I think you get 5 volts out of that without even have a battery hooked up, but you should have a battery hooked to it. So just some of the neat toys you can get for solar power.
A charge inverter or a charge controller similar to that
Mhm.
one. You have to have a battery.
Probably do,
hooked to it
for it to
turn
switch.
on.
Right. Probably
I
detect
thought
what,
something was wrong for
Yeah.
a while,
It probably has to have the battery to detect. In fact, you're right. If I have one of these up, you have to have a battery for it to know what voltage.
And then you might as well also put a good load dump on there.
Mhm.
That does something, like in the summer, you could have it,
Yeah.
like load dump as a fan.
Yep, you can have a fan or a DC fan or a light bulb or anything on there. Yep, keeps the power regulated smoothly, especially if you want to use that USB to charge your appliance. This has, 20 amp, 12 or 24 volt solar charge controller. But these are pretty neat. They're great in emergency. You got a power out situation. I got several of these around the house. I bought $10 a piece. I could quickly hook up a couple panels and a couple car batteries, and I'd have some power. I could put it together. If you had a, natural disaster, earthquake, anything, I could generate some power, enough to run a microwave, enough to run a refrigerator or something like this. So that's something to think about.
If you did something like that, what kind of time frame would it take to recover the cost of your investment in terms of what you're saving in your power bill?
On just grid tie, you talking about just grid tie or battery? Because battery's a whole new ball game. Battery can get very expensive.
Okay, so
If you want to just do grid tie to lower your bill, like this time of year, I'm probably making close to $100 a month off my bill with those 9 panels. I got 9 hand wall panels, the new company that started up in Dalton. It's those type of panels, the Q cells. Theoretically, I call it a 3,000 watt system, but it really only generates about 2750. And minus your 10%, 2,500 on a good sunny day. So, yeah, I'm probably doing close to $100 a month this time of year. Wintertime, more like 50 or 60. Days are shorter.
So with the cost, it's about 3 years,
Yeah, if you do it yourself, I calculate about a 3-year return.
not battery.
Yeah,
If you want to do battery stuff in that time,
yeah. Batteries can get expensive.
Batteries really only used for like emergency stuff, like when people.
Yeah, yeah. Batteries would be, right now, lead acid, something like that, even some lithiums, probably just emergency use. Getting a big battery bank can be very expensive. Guys spend $30,000, $40,000, $50,000 on some of their systems.
Like refrigerators, so your food doesn't spoil.
Yeah.
Maybe a heater.
Yep. Even just a few deep discharge lead acid batteries could get you by an emergency situation. Yeah. I'm not off the grid. I'm on grid. I have to have grid power. I'm just reducing my carbon footprint and reduce my energy consumption.
You could, in effect, be on the grid, but then battery backup if you, like, you can have your emergency backup, but just running off of,
Well,
charging off of.
me and Dennis had this conversation the other day. My big solar inverter, I can't bring it, it's 150 pounds, but the big solar inverter that converts that 2,500 watts to 240 volts AC and sends it back to the power company, it doesn't run if the power goes out. It's a UL lifted inverter. You want everything UL lifted if you're going to do anything with the power companies. They're going to demand it. And I've got a good contact for Georgia Power in Atlanta to get these inspected. They come out, inspect it, reprogram the meter, everything for you. But it all has to be UL 1741 lifted, which means if the power goes out, the inverter shuts off. Because you wouldn't want 2,500 watts of power going back to the street. It'd go through the transformers, it'd step it back up to 10,000 volts, whatever the voltage is. And if there was a lineman working on the power lines, you'd electrocute him. Literally. So, yeah.
And there would be no way for it to be regulated.
Right. So the inverter doesn't, the solar inverters do not generate a waveform. They match the waveform of the power company, the sine wave. In fact, when you first turn on, when they first power it up with DC, it's got a cutoff switch, it takes about a minute for it to sync. And then the green light comes, it'll say syncing, and then it'll sync. Yeah, it syncs with your AC coming through the wall. That brought up a good point. What if you completely isolated your breaker box and you took a sine wave inverter like this, a smaller one, hooked it to your breaker box? You could power up your big inverter and you could run big appliances as long as the sun was out with no battery. So I've actually seen it done. It's not recommended, but
Is it more expensive to sell back to the power company?
well, it's
If you were gonna go.
no, it's not more
off the
expensive.
grid,
Yeah, you'd be better off to do batteries, but it costs so much to get started because of
I see.
$1,000 batteries. The good ones,
Right.
even lithium. Yeah. Plus you got to maintain them. If you get lead acid like golf cart batteries, You know, say you get 16 of those, put them in your basement for 8 in series for a 48-volt system.
You'd be lucky to get 5 years.
Yeah, you're going to hammer those batteries. The more you get, the better. Most batteries, even these type, handle a lot more charge cycles if you don't drain them, more than 80% of the max. Is that what it is, Kevin? About 80% is recommended?
The
If,
thing is,
if you only drain them,
a lot of your lithium ions actually have built, like Dennis mentioned earlier, they actually have built-in electronics. They have undercurrent and voltage electronics that will detect when the lithium ion cell is almost dead, and they prevent it from dropping below a certain voltage.
Yeah.
So if you take a voltmeter and you actually were to measure a dead lithium ion cell.
it's just like your,
Your knockhead cordless drill.
Yeah.
You go,
Yeah.
and then
Yeah.
your lithium
That's
ion
funny.
drills, it just
they,
stops.
there's a circuit in the drill which stops it around 40 or 50% to save the battery.
It just stops.
There's more power there, but it won't let you use it. Your cell phone's the same way. Your iPhones, that battery gets down to about 50, 60%, phone shuts off. It says it's dead, but it really isn't. Take the battery out, there's 3.6 volts in that battery instead of 4.2. But in order for it to handle several thousand charge cycles, they deliberately kill it ahead of time.
Now, the difference is Dennis mentioned the lithium ferrite phosphate batteries earlier.
Lithium iron phosphate, yeah.
Yeah, those, they have some newer versions of that coming out this past couple of years that maintain a steady voltage and overhead. They'll hold, 13.8 volts right up until the moment that they're about to die.
This battery doesn't need a balance charger, does it? It's just 12 volt. It's built in, yeah. That's another advantage of the lithium iron phosphate is they balance all the cells when they're charging equally. They're
That
built
one-
right into the batteries.
That one holds 13.7 until it shuts itself off.
Yeah, there's a brain in there, CPU.
That's $900
Very expensive batteries.
to set up. But
Yeah. Although I did see a video the other day where you can find them used on eBay, about $150. Come out of medical equipment.
Get a more of a carpentry roof, like, so here on your house where you
Mhm.
mount your panels,
Right.
what are the considerations for the type of roof you have, metal versus asphalt shingle versus leaks versus wind?
The best consideration is keep your panels above the roof. Don't want them flush. You think, why not? Well, they'll get too hot. Solar cells are more efficient if they're cooler. In the wintertime, they could put out 10, 15% more power in the summer because, if it's 20 degrees outside, the voltage would go way up on them. So they're way more efficient if you can keep them cool. So you don't want them in a situation, even on a metal roof, where no air can flow underneath them because the heat build up under there maybe a couple hundred degrees. Shingle roofs would probably ruin the shingles. So I got mine a good 4, maybe 4.5 inches above the shingles. I use the metal unistrut like you buy at Home Depot. Mounted that to the roof. I used some lag screws and some spacers and some flashing. I filled the whole thing with black roofing urethane. Never had a leak problem.
You don't really notice it too much.
Yeah.
We were reading online a few years back that you want a minimum of 3.
I've seen people lay them on top of a garage, just lay them up there.
Shingle roof, you want a minimum.
And they stay there a while. I'm surprised they don't blow off during a strong wind, but I guess if they're just laying there, the wind can't get underneath them. But you want to mount them securely. This is unistrut bolt. Goes inside the metal strut and you turn it, and then it has a big heavy square washer, 3/8 bolt. You tighten down 2 panels at once. So when you got these bolted down to that unistrut, they're not going anywhere.
You start up, they're real simple.
If they come off the roof's going with it. I got them lag screwed right into the joist, yeah. If they blow off the roof, they got bigger problems.
If you have a big enough system that you are selling more power than you're using, is there any point at which the power company will send you a check for the overage?
Yeah, if you get a big one, this grid here, the one with 36 panels, does about 10,000 watts. If you get 5 good hours of sunlight in a day, that's 50,000 watts. How much is that in a month? 50 times 30, that's 1.5 megawatts. So this system I put in, this is down in Adairsville for a friend of mine. We put a big one out in this cow pasture, basically. And it's in the sun practically all day. About 9 o'clock in the morning, it's above the trees. Then it's in full sun till sunset, where it's sitting, pointing straight south. And this one's even tiltable. You can tilt it from summer to winter a little bit. Each one of these assemblies weighs about 1,500 pounds, but it tilts pretty easy. It's all balanced. But he would probably get a check, except for the fact that he uses a lot of power. His electric bill used to be $350 a month, winter, summer. Now we got him down to about $160 with that big system. Now, if I had that system there, my bill might be zero sometimes, but you have to sell back 3 to 4 times as much as you're using on a given day. So if you use 30,000 watts a day, if you really wanted to make money on it, you'd probably have to have 100,000 watts or 50,000 watts to really get a decent check back.
Do you have to put them on your roof, or can you put them in your backyard?
Hmm? Yeah, that's a ground mount.
Some states have a requirement.
You can cement
but here in Georgia,
wooden posts. We use 6x6 under that to hold it up. You can use metal, whatever structure you want to build. Just make sure it's something that's going to last.
All right.
The solar
How
cells
far off the ground do you want them?
depends on where it's at.
if it's in
All right.
if it's in the middle of a cow field, I would recommend.
Yeah, this was in a cow field, but we changed the fence, so the cows can't get to it. So there's no regulation to it. Most people tend to go lower.
Common sense.
Yeah, most people go low, like the low end of the panels, maybe a foot high for structural strength. If you go up real high, you're more prone to wind damage.
Hard to work on.
Strong winds could damage it. Don't want them so high it's hard to work on. It's the only problem with my roof is it's up on the roof. Of course, the only thing I have to go up there for is once every spring I got to wash them with a squeegee, get all the pollen off them. It kills about 5% of the power. So, yeah, once a year I go up there with a hose and clean them off. Minimal maintenance.
Do you notice a temperature difference in your attic on that side?
It should be cooler, yeah, since the direct sunlight's not shining directly on the roof.
You are converting some of that light.
Mm-hmm. One picture here on the first page, the bottom left, that's actually a friend of mine. That's on a mobile home. We ended up putting 18 panels on a mobile home. His power bill in the summer, $60, $70 to cool his house, 70 degrees.
How big does the hail have to be before you get it?
Most of the panels, they come with a spec sheet when you buy them, or you can look it up online. Those are rated for, I think, a 2-inch piece of hail going 90 miles an hour, won't break them. They're pretty tough. It's a tempered, yeah, they're tempered glass. There's videos of them, where they shoot glass straight at them, or hail straight at the glass, and it takes a pretty good chunk of ice to break them.
But once an individual panel is damaged, it's trash. Right?
You got to change it. Yep. It's good trash. That's another thing about solar cells is if you have a panel with 72 solar cells and one cell gets in the shade, it no longer conducts electricity. It kills that whole panel. So every single cell needs to be exposed to sunlight. It's kind of like a dead battery in the circuit. There's no photons hitting those electrons and knocking them loose, so that one cell dies. And a lot of people don't realize this, but if you build a big solar panel, they have a diode built into the connector box on the back. There's usually a diode assembly in there. It's a blocking diode. So when the sun goes down at night, no power flows backwards out of your batteries or your charge controller. Most of these should not let power flow backwards, but you never know. Especially if it's made in China, it could. So they block the power from going back because it could drain your batteries at night. And a lot of people don't realize this, but if the power flows backwards to this, what happens?
It glows.
It glows. It turns into a LED light. You'll see a faint glow. They'll glow like a weird color blue. You'll see a faint light on them if the power is flowing backwards, but you'll never see it because they put diodes into the panels. So you don't want to light up the neighbor's house when the sun goes down. Well, that's about it, guys. Unless you have any more questions. Anyone else have any questions?
9:15, so we can a little bit longer.
Thank you.